to, and then back end be gone in earnest. So I was writing C sharp, and it was good. It was a beautiful experience. When I always it was a beautiful experience that I've been saying is that after being in venture gardening group for a couple more years, I wanted to I wanted to um use what I learned in my masters. So I wanted to do something more business oriented, more people oriented, and that was when I moved to Andela, um, which which is also present in Ghana. Um, so what they do in Andela is partner engineers with companies in usually US. So companies in US who need engineers and can't find any would come and hire engineers in Nigeria and some other Ghana and some other countries. So my role as a partner engineering manager was pretty much to get what the customer or what the partner needed. So if a partner says, these are the kind of products we have, this is the language that we use, it was my job to look through the engineers that we had. Do you have the qualifications that this partner needs? If you have some and you don't have some, how do we ramp you up, or how do we increase your knowledge so that when you get on the engagement you are successful? So I do that initially, and then when the engineer is on the engagement, the next step would be for me to support the engineer through the process or through the engagement until either the partner wants something else or they're just there forever. After a year of doing that, I liked it, but programming was my first love, and I had to come back. I felt like I had lost touch. And a lot of people say, oh, you could have done programming on the side. Yeah, I could have, but it was different. I wanted to be in the system. And so when the opportunity to go into Microsoft came, I took it. I grabbed it hands and legs. So now in Microsoft, I work with the test-based team. What do we do in test-based team? We create a testing platform. That's why I'm happy that testing is part of the things that I'm talking about today. We create a testing platform so that customers can test their products against pre-release of Windows. So you know that we just released Windows 11. If you were a customer and you had an application that would be installed on this Windows 11, before it came out, you had the opportunity to come to our platform and test your application, so that when before Windows 11 is released, if there are any issues, you could have sorted them out. So apart from the checking bugs and failures, we also return results from regression analysis. So CPU regression, memory regression, and all of that. That's what we do on the test base, and that's where I am currently. Are there any questions before I move into the topic for today? No? Okay. So down the line in the course of this presentation, I would ask questions, and it would be nice if people can come off mute to share their opinions or their thoughts, just so that I'm not the only one talking, and I'm sure that you're getting something. The goal of this is so that it's not just for you to know software design and implementation theoretically or software testing theoretically. I want you guys to be ready such that when you graduate, even before you graduate, for people who are taking personal projects, when you want to implement something, you know how to go about it. And for the course of this, we'll be using the use case of the hospital management system for explanation. All right, so we'll jump right in. We'll start with design. So design and implementation are part of the software development lifecycle. I don't know if you had covered requirements gathering and analysis, so I'll just run you through it, or I'll just say what it is. It's the phase of the cycle where you get information. So what does your customer want? What does he want to achieve with this product? We said we're using a software development. Sorry, we said we're using a hospital management system. So we want to know what you meet the, let's say, the head of the hospital, the group MD. I don't know if that's what they call head doctors, and he says, I want a software for my hospital. What I want in this software is that a patient can come and a patient can come in or can log on. A patient can view their records. A patient can make an appointment, book an appointment, schedule an appointment. A doctor can also come into the site, check patient's information, update patient's information based on meetings, have meetings. A receptionist can, when a patient comes in, a receptionist can match the patient with an available doctor. All of these things. So all of this is gathered and put in a specification document. Now, this specification document is what we would, it's like the input to the design phase. All right. So, because I said the requirement phase is focused on the what, now the design phase is focused on the how. The doctor wants a patient to log on to the system. How? The doctor wants the patient to be able to book an appointment. How? He wants the doctor to be able to log on to the system. How? So how do you want to achieve all of this? This is where the design phase comes in. So it takes the specification document that has been prepared at the requirements phase and converts it to something that can be directly converted to code. So it should be detailed enough so that when it's time to write code, the programmer is just thinking of implementation. The programmer is no longer thinking of how, he's just pretty much writing the code. Okay. So a bit of definition: it's the process to transform user requirements, which I had said earlier, to some suitable form, which helps the programmer in software coding and implementation. So all the requirements that have been gathered are now translated to software components and shown how these functionalities or these things that you want the application to do can be made possible. Okay. I can see that there's a hand up. Do you want to ask your question, or can I continue? Okay. Bernice. Okay, great. So the activities in the design phase would be to decompose the system into modules. Now we have the big system. The big system is the hospital management system. How do we modularize this? We'll now say, it's at this point we'll say, okay, we have the booking system. We have the system for medical records. We have the system for lab tests. So we're breaking down the whole system into modules, and then we now show how these different modules are going to talk to themselves. How is the let's say the registration, because I'm thinking that a patient would have to register to even use the system. So how's the registration mapped to the user details? How's the user details mapped to the doctor's details? How's the doctor's details mapped to the patient's medical information, and all of that interaction? So your design should show that. So the next thing is different modules are designed in greater details. For example, in each module, it should be detailed enough to say this module, we're using this data structure. In this class, the name is a string, the ID is a GUID. That's detailed. That it should be that detailed. All right. So design is done at different abstraction levels. So although I'm saying it should be that detailed, it comes in levels. There's the architectural design phase, which is really large, the high level design phase, which is relatively large, or high level, and then the detailed design phase, which goes into more details. All right. So I said the architectural design, which I said initially is the largest, is the highest abstract version of the system. It defines the system as a whole. It doesn't break down into modules or any of that. It's just super high level. Next. Okay. Then the high level design phase is now where modularization happens. So that's why it is at this point that you break down the system into different modules, into different components. It's at this point that you show how those components talk to each other. What I have here is high level design focuses on how the system along with its components can be implemented in form of modules. It recognizes modular structure of each subsystem and their relation and interaction among other stuff. This was what I was explaining earlier when I said, how does registration link with patient records? Modularization, this is just a definition of what I've been talking about. Modularization, it's a technique to divide the system into multiple discrete and independent modules, which are expected to be capable of carrying out tasks independently. These modules can be executed or compiled separately and independently. So when you're modularizing your system, you want to, as much as possible, make a module to be able to stand alone, so that if something breaks in another module, this module should not be affected. It should stand alone. You should be able to run it beginning to end on its own. Right. And then the detailed design phase is is pretty much what the developers relates with or talk to. So the high level and the architectural doesn't help the developers as much as the detailed design phase. They're good, but when you're implementing, this is your point of truth. This is your point of call, because the better the detailed design phase is, the quicker your work as a developer. All right. So after functional modules are identified, the detailed design of these modules are worked out. Detailed design deals with the implementation parts of what is seen as a system and its subsystem. So how are we going to implement this? What methods are we going to have? What classes are we going to have? What are we going to reuse? What exists that we're going to reuse as detailed as that? It defines the logical structure of each module and their interfaces to communicate with other modules. At the end of this phase, the detailed design document is released, providing the base for implementation. So this detailed design document that is released is the Bible for the developer. I don't know if you understand. And I know that in your last class you did modeling. So we're going to do a bit of modeling. So other modeling that you learned last week. Today is practical class. We're going to create models for this our hospital management system that we are building. All right. I'm sure this is a recap of what you learned last week. UML, so it's a general purpose modeling language. The aim is to define a standard way to visualize the way a system has been designed. There are two types. There's the structural diagrams and the behavioral diagrams. So the structural diagrams capture static aspects and the structure of the system, while the behavioral diagrams capture the dynamic aspect. So it captures the flow of events. So structural diagrams can now be component diagrams, object diagrams, class and deployment diagrams, while the behavioral that would now have use case diagrams, state diagrams, activity diagrams, and interaction diagrams. Okay. So I have, following this slide, a couple of diagrams for our hospital management system, but I don't want to go into them. I want you rather, us to come up with, or I want you guys to tell me what you think. We'll start with the use case. I want you guys to tell me who you think that the actors in a hospital management system would be. If you are too shy to talk, you can type it. Any of the actors that will be a part of the use case diagram for a hospital management system.
You will see the doctor.
The doctor. Beautiful. So the doctor is one. David says the patient. Beautiful. Any other person? You go to the hospital. Health professionals, the patients, the admin staff. When you said the admin staff, it's funny how these people get overlooked, but they're important. The receptionist, yes. Any other person? Administrative staff, the nurses, record staff. Beautiful. Okay. Now, next, please, if you can unmute, that would be nice. What do you think that the doctor's role, not the doctor's role in the hospital, what do you think that the doctor should be able to do in our health management system? Who was the first person to say doctor? All right, someone has unmuted.
Prescribe medicine.
All right, so the doctor should be able to prescribe medicine. Any other person?
The doctor should be able to update the patient's records.
Beautiful. So when a patient comes and has complaints, the doctor should be able to update the records based on the complaints that the patient had. Any other thing?
He should also be able to advise the patient.
All right. Now, this advice can.
Okay, so I wanted to say that he should be able to check the patient records.
Yes, he should be able to view the patient's record, because I mean, how are you diagnosing a patient without his information? So yes, you're correct. And then I want to go back to the person who said he should be able to. Oh, now I can't remember. What was the last thing someone said? Uh,
Advise the patients.
exactly. So
Update the
now I'm
records.
thinking, no, it was advice. How do we implement, or how do we now put in advise the patient into our system? Should we, no, I'm not, no options, but how do you think that we can have that in our system? What's the use case for it? I don't know if you understand my question. So a doctor should be able to advise the patients. Great. Now, how do we store this advice in our system? Do we want to say, oh, in the patient records, we would have diagnosis, and then we'll have recommendation, or would this be part of the system, or is this something that the doctor is just telling the patient offhand? Okay. All right. Next, who's the remarks? Beautiful. Yes, remarks. Remarks would work. Next actor that we said was the patient. So what's the patient? What are the actions that the patient does on this, or is expected to do on the system? Please, the ladies, guys, please, let's give the ladies like 2 minutes to. Mr. Mark, I'm not sure what's the percentage of ladies in the class. Mhm. Okay. Yeah. I think it was about the same thing when I was in school. It was like 30%. When we were in school, it was 30%, but now the number of people who remained in IT, maybe like 10, maybe like 5%. All right. All right. So, ladies, please ask your question so that when you graduate, you remain in IT, you will not abandon us. Mhm. All right. So, we are talking about the patient now. What should the patient be able to do on the system? Is someone's hand up? I can see a hands up. Who for?
Book for appointment.
Book appointment. Yes, correct. The patient should be able to book an appointment to see a doctor, to do whatever he or she needs to do in the hospital. Okay. Ooh, a lot of hands. Okay, please just unmute and then say what you want to say.
They should be able to view their records.
They should be able to view their records. Yes.
They should be able to view their prescribed medicines.
Their prescribed meds. Correct.
They should be able to cancel appointments.
Yes, that is also very correct. And I can see in the chat that someone said they should take their medicine as prescribed. Okay, so this is important, but how would this be in our system? Will we have a part of the hospital management to track medicine intake? Right. So any other? Okay, more hands. Nana.
We
I I didn't hear what you said.
I think for tracking the medicine intake, it will have to be for those people in the hospital. That will be simpler. But for people who have left the hospital, it will be a bit difficult.
Yeah. So, all right. But then in that case, it wouldn't be the patient who is doing this. So to track what, let's say the patient is admitted, to track the meds that they have taken. The patient is not going to come from the hospital bed to say morning dose of malaria medicine taken. That would be more of a nurse's work. Or what do you guys think?
Hey.
Certainly agree.
Righty. All right. Any others for the patient?
Give a
Please come
valid
up.
I,
ID.
I,
I didn't get that.
I think the patient should be able to make inquiries without booking an appointment.
Sure. That is correct. And that would mean that if they're able to make inquiries without booking an appointment, there should be another part of the system where someone is responding to these inquiries. Great. Thank you. All right. Next, next actor should be, let me go through the chat again, see what we have. The next actor should, oh dear. Receptionists. What do you think the receptionist should do? Any ideas? Or should I give the ideas?
I think the receptionist should be the one in charge of the inquiries.
Good. Yes. So they're on the other end responding to those inquiries. Also, when a patient comes in, the receptionist should be the one to check availability of the doctor and say, oh, you have a patient now, so you can go in. Okay. Now let's open the UML. Thankfully or not thankfully, the UML that I have doesn't have all of these details that we talked about. So if you feel like if you want to expand your knowledge, I think that it would be a wise idea to create a UML by yourself for the system, just for your own knowledge, so that they say that when you learn something, it stays somewhere. When you now do it or when you practice it, it sticks more. So please, if you have the chance, I think that you should draw up a proper UML for this. All right. So here we have the receptionist, and these are her tasks. Schedule patient appointments if the patient doesn't want to do it online. So patient registration, schedule appointments, schedule hospital admission. Sorry about that. File insurance, file medical reports, and all of that. All right. Next diagram. The next diagram I want to look at is class diagram. Now we've said the actors. Now can you tell me how these actors can be classes? So we have a class for doctor. What should that class entail? What you can see on the screen is still the use case diagram, but now I want us to move to class diagrams, but I don't want to show you yet. I want you to tell me what you think should be in the class diagrams. Or can you still see my screen?
Yeah. Yes.
Okay, great. All right. So can someone tell me what classes you think? And remember that you want your classes to be able to extend from other classes. So if there are classes that are generic, you don't want to have, okay, so an example, a doctor is a person, a patient is a person, a receptionist is a person, and everybody has name and let's just say name and gender. You don't now want to have name in doctor class, name in patient class, name in receptionist class. You know that all of this can just derive name from person attributes. Am I correct? Or do we know about that? Mic check.
No, please, I still
Yeah,
don't
yeah,
quite get it.
yeah.
Okay.
Please, oh,
Let me just share the screen. Great. So this is a class diagram. If you can, now I don't know how to zoom in. Oh dear. No. All right. I don't know if you can see what's going on here in the
Yeah,
person
we can zoom
class.
in.
I'm not sure how to zoom in.
No, we can zoom in by ourselves.
Oh, you can zoom in. Great. All right. So I don't know if in this person class, can you see that it has name, it has title, it has gender, and it has date of birth. You can see all of that, right? Now, from this person, you can see that patient is gotten from this person. Operation staff, all all of this or inherits from this person. So if you come down to patients, you don't see name, title, gender because it already has it in person. Do you understand what I mean? I don't know if this is now too abstract. Okay. Someone's hand is up. Do you have a question? Oh, I think his hand has been up since. All right. Um. Okay. Okay. Great. Now, this is how a class diagram looks. Class diagrams are so detailed that they have the attributes and they have the methods. So we have said that a patient should have name, title, gender, date. What should the patient be able to do? The patient should be able to visit. So these methods, visit, admit, write prescription. What are the other things that we said people should be able to do? Anybody at all? Um, give it to me. Advice will come in as a
Book
method.
appointment.
Book appointments will come in as a method. So it should be that detailed such that each class has those details. So those actions that the person can take. Any questions so far? Okay. So there are two more diagrams, and there is the activity diagram and the sequence diagram. So the sequence diagram shows how activity moves from one person to another, how information is passed from one person to another. An activity, oh, this isn't clear. And then activity diagram also shows activities, like, but this isn't like from one person to another, it's just what happens. Okay, and that's all that I have for design. Please, any questions? We are moving to implementation. Okay. Right. So before implementation, I saw this quote on one plural size course, and I think that it is
Hello, madam.
mean.
Can you please take the
What?
activity diagram again?
Can I take I think I would have to. The activity diagram is not clear, but it shows sequence of events. So if you can't see this, it starts with patient takes an appointment, yes or no. So it's like a flow chart. If the patient takes the appointment, um, then you now check if the doctor is available. If the doctor is not available, cancel. If the doctor is available, book appointments. That flow of events. Any other questions before we move to implementation? All right. Implementation. Yes, so I was saying that I saw this statement in one plural site course, and although it was mean, I liked it. It says any fool can write code that a computer can understand, but good programmers write code that humans can understand. I don't know if you have ever had to read someone else's code. It usually is a hassle, but it gets easier when the other programmer is a good programmer. So if it's don't know what's called a programmer that is not so good, um, you would find it difficult to read their code. You'll be where was this implemented? Why is this being called here? You're just going to be confused. But if it was written properly, if it was written well, then I mean you'd be able to read it. And so we move into implementation. This is also part of the software development lifecycle. This is where it's time to roll up your sleeves and write some code in whatever language that you have decided to choose. So, right, this is where development or coding happens, where the product gets built. The design, these beautiful designs that we have come up with from the design session, it's time to write the code for it. Please, your code should be simple and readable. Not when you're writing code, it's not time to show that you're fancy or you're brilliant and you're not going to write method that only you understand. It should be simple, readable, straight to the point to do what it's supposed to do. Don't go and add what isn't supposed to be added. So simple and readable means that it should be easy to maintain. You don't want to write code that if for some reason you have to make changes, you're going to break other things. So you're going to write code, and another thing that is not even affected by anything is breaking, is crashing. So it should be easy to maintain, or you want to make a change and you can't even find where to make the change because your code is clumsy. It should be easy to review. So what these days, there's peer review. When you're working in a team and you write code, you don't write it straight into, it's called a branch, straight into the master branch or straight into the dev branch. When you write your code in the branch that you've created, you want to get someone to look at it. You want to get someone to say or to check it, just to be sure that you wrote correct code. So if your code is not easy to review, it means that you did not write it well. Sometimes people will write code and nobody wants to review their code because nobody understands what they are doing. You don't want to be that person because it just slows work down. You should be able to evolve, change over time. You should be able to test it, and you should be able to document it. Your code should follow coding standards as well as best practices. All right, so we would talk about the coding standards and the best practices like in the following slides. All right, so coding standards are the rules and the guidelines that determines the programming style, procedures, and methods for a programming language. The standards can either be what you want in your company or standards that have been set in the world. So those are like the external standards. All right, so if the benefits of having your code follow proper standards is that there's easy team integration. Easy team integration is a new developer comes to your team. If you're creating, if you're not following standard and you're just writing code anyhow, and the person wants to integrate and write code and add to it, it's going to be very difficult. Now it may be a bit easier for people who are already in the system because all of you are writing the what I call it beans, are writing the clumsy code together. So those ones will be able to cope. But imagine someone coming from outside trying to make impact to like trying to add to this code. He won't be able to because standards were not followed. It increases code quality efficiency and easy for maintaining. Same thing I said. And for these guidelines to be created, a lot of research has gone into it. They've been researching about it for a long time. So it's not sudden implementation. It's something that has been researched and proven over time. It reduces code complexity and then reduces the cost on development because you're not wasting time. So development cost is saved. So common aspects of coding standards that are looked at: naming conventions. How do you want to name your classes? How do you want to name your methods? How do you want to name packages? How do you want your file and folder structure to be? Where do you want tests to be? Where do you want libraries to be? Where do you want your bin folder to be? Formatting and indentation. Do you want to indent? Do you want straight line? Do you want your when you start a new method, do you want your curly brace to be immediately on that line? Do you want it on the following line? Simple things like this. How do you want your code commented? Do you want comment every single line of code? So string A, you now say A is for Apple, or you want your commenting to be for the whole class or the whole method. Okay. Oh, hands are up. Great. All right. Please ask your question. Kufor and Albert. Is that a mistake, or can I go on? All right, I'll just go on. And then for best practices, follow existing design best practices. Modular design, decompositions, solid. Solid is like number one. I don't know the full name again, but you want you remember when we said we are modularizing in the design phase. Now, when you're writing code, let that modularization stand. Let each module be able to do what the module is supposed to do. Let the interconnection not cause a break in one module to affect a break in another module. Let's when you're writing your classes, you don't want one class to do more than what it's supposed to do. If you say a class is doctor, I don't want to inside that doctor class, I don't want to see receptionist work. Like, it should be, I said this class is for this. I said this method, a method is to book appointments. In the book appointments method, that is all there should be. Your method shouldn't be so long that it begins to do things that are not part of the name, right? Your code should be reusable. So if there's any code that you think, write your code in such a way that if another person wants to use it, they can just pull it and use it instead of having to write it again. Now, remember when I was saying that you have a class person that already has name. You don't want to now create another class patients that has name again. So now patients is going to reuse the code from person. That way, it makes your project concise, straight to the point. You're not having one thing in multiple multiple places. About writing reusable code, it's also important to reuse the existing code. You don't want to reinvent the wheel. There are things that are existing. There are libraries that are existing. Don't go and start creating from the scratch. Nobody asked you to go and create string. So instead of writing string, you now write an array of characters. Please just use string and rest. Don't overcomplicate your life. Okay. Any questions? Moving on to software testing. Sorry, we have like how many more minutes, and I want to finish testing. Okay. All right, Daniels, what's your question?
Good afternoon.
Hi.
Yeah, and my question is that you see, you're talking about the abstract, the modularization rather, and you said one module or one class shouldn't cause another class to fail or something. So what if that class or that module actually depends on that one that's calling it? What would be the case?
So that's the concept of modularization. So you don't want try to build your system in such a way that the breaking of one will not cause the breaking of the other. So when you're building this class that is calling another class, just check from the beginning. Maybe do validate the input. So even if that fails, even if the dependency class fails, the class is calling is not failing. So you're returning it. Oh, I am expecting a string, and what you're passing is null. Check it from the beginning. Return. This is failing. This is not what I'm expecting. I don't know if that answers your question.
Oh yeah, I've gotten it now. Thank you.
Great. All right. Software testing, which is the last part of the class today. It's the next stage in the development life cycle. It is, before we start, if you write a program, if you write a software and you see bugs in your software, it's not time to be frustrated. Well, I want to say it's not time to be frustrated, but sometimes it is very annoying. It's even more annoying when you cannot find the source of the bug, but it is normal, and it happens to everybody. Like, it happens to the best of developers, it happens to upcoming developers, it happens to mid-level developers. Bugs occur. So to reduce the number of bugs, it's best to not leave testing to the end of the cycle. So you will now say, I'm done writing code, testing time. Both of them should be hand in hand. Both of them should be and done at the same time. So you write whatever you write, you test it. You write whatever you write, you test it. Just so that aside like doing everything together, it also reduces time spent. So if you've written a code like 3 weeks ago and it's now that you want to test it, you may have forgotten some things, but if you're testing it hand in hand, you easily know where to go and make like the changes that you want to make. That said, we have two types of testing: manual testing, automated testing. Manual testing is, I want to click on this button, I take my mouse, I click on the button. I want to drag this, I take my mouse, I drag it as a human being interacting with the system. No tools are used, just manual interaction with the system. Automated testing, however, is where you use automated testing tools, and there are a lot of them that get used or that are being used in the industry at the moment. Right. Testing levels: unit testing, integration testing, system and acceptance. Unit testing is the one that the developers do the most. So you write code, you write a block of code.
Hello, you said there are two types of testing: automatic testing and what was the other one?
Automated and manual.
Okay, thank you.
Right. All right, so for the unit testing, this is the developer's baby. You're writing code to test code. So we have said this code, we want to write a code, um, we want to write a method, book appointment. Now we're going to write a unit test. In fact, a couple of unit tests to test that book appointment. For this small book appointment, you can have like 1 million, okay, not 1 million, you can have a lot of tests for it. So you're going to test when they enter valid parameters, when they enter invalid parameters, when they enter valid parameters but the system cannot find it. So these are the different these are a couple of scenarios that you can look at when you're writing your unit test, and then based on whatever it is that you're implementing, your unit tests would be for that. Right. um Next is, so the unit test is like most granular type of the most granular level of test. Now after you've created unit tests for each module, you now want to do integrated tests. So I have written I've written the part, the module to book appointments, and I've written the modules for registration. I want to now test them together so that I'm sure that after the user registers, the user can book an appointment. That's integration test. So how is this new model integrated in the whole system? Next is system test. So you're testing the whole system. You've built all the modules, you've integrated all the modules. Now you're bringing everything together to test. This time you're testing functionality against what was in the requirement documentation. You're testing performance testing. Are you sure that this code we wrote is not consuming more memory, consuming more power than it should? You're doing security testing. All of that is done in system test. And then the last one would now be acceptance testing. So you are using the system as the end user. So there are two stages to this. There's the alpha testing and the beta testing. Alpha testing is when the developers come and use the whole system as if they're the end users. And then beta test, for example, in Microsoft, in Microsoft, when a new product comes out, we don't immediately after development, it's not available to everybody. So some customers test it, and then it comes to public preview. So if you notice that there's some Azure products that you want to use and you see public preview, it means that we are still in the testing phase. So if you want to help us test, please come on board. And then it's now open to everybody after that testing has happened. And that is it for software testing. Any questions? Okay, so what I tried to do was throughout the okay, please hit me with your questions. You can just unmute and ask your question.
Hi, good afternoon.
Hello.
Please, I have a question pertaining to your experience and whether while you were going through the journey, you had like a mentor. Because usually it's better to know what to do than to like be making unnecessary errors that can be avoided. So do you have a mentor, and personally, are you willing to like be open to become a mentor for girls in this class? Thank you.
You're welcome. Okay. I had a couple of mentors. I won't say I had a mentor. I had mentors for different areas of like. I had a mentor for career progression. I had a mentor for very technical related stuff. And yes, they both have helped me so far. And yes, I am willing to be a mentor because I mean I have enjoyed it, and it's only human to extend this enjoyment to other people. So sure, I'm open. I'm even more open to girls because I really need us to be more in the field. I can't be okay. So in my current team, thankfully, it's about 50-50. But all the teams that I've ever been on, if I'm not the only girl, we're only two girls. It's usually like that. So please,
Okay. Hello.
Okay, hi.
hi,
Okay, I don't know if you can hear me clearly.
I can.
Okay, thank you. So I have three questions,
Oh
and
wow.
I'm going to ask all of them and then let you go ahead and answer them. So
Okay.
the first one is you mentioned earlier that in the field there are not much women, and then also because they get discouraged at the end of it all and they go into other fields. Well, I think that personally it's because some women cannot balance software engineering with their homes, right? Because it's a major task. Software engineering, when where you have to program, it takes some time and you need attention, and then you have to split that between your home and then your work. So how are you able to balance it personally? That's the first question. The second question is about getting into Microsoft.
Mhm.
So how did you go about it? What were the steps? What were your setbacks? What were the procedures? What did they require? Like, how did you get into Microsoft basically? That's the
Okay.
second question.
Mhm.
And then the third question has to do with your master's, right?
Mhm.
You mentioned that you did a master's in information systems and business analysis, right?
Mhm. Yeah.
Yes. So, how did you finally decide to go there? You mentioned something about it, but I didn't quite get the explanation. So, how did you decide to go into the business world? Because information systems and business analysis is, I don't think there's hard coding there.
Mhm.
So, I don't know, shifting from your first love, as you said, and then moving into this aspect, like how was the transition like, and how was coming back to your first love like? So basically these are my three questions. Thank
Okay.
you.
All right. Thank you, Dorcas. So first question is work-life balance. The thing is, I don't know if it's easier for the guys to be any work, whatever work it is, or whatever you find yourself doing, this will still come up. So whether you decide to be a software engineer or any other thing, you will still have to balance your life. If you have children, your children. So what I do is I make or I try to get as much help as I can so that nothing suffers. So at home I outsource a lot for my child. I have a nanny. For food, I try to do weekend cooking, and we warm through the week. It reduces the amount of time that I have to think of like home related stuff. But I may not be in the best position to answer it, maybe because I don't have a lot of children yet, or my responsibilities are not as many. But for the stage that am with the one child that I have, I'm able to balance it because I get help and I'm able to outsource. That was a hack that one of my mentors gave me. So I told you I said earlier that I had a career progression mentor, and that was one of the hacks that she gave me. Get as much help as you can, and that's working for me. For getting into Microsoft, they opened the African Development Center here in Lagos, and they were employing software engineers. I applied on the sites, and but there's there was a lot of reading involved. Um, Data structures and algorithms, system designs. So these things that are looking random in school, I remember that I took, I think, about 2 weeks to do revision. I was doing whiteboarding, writing code on the board, checking data, different data structures, writing algorithms. The one search, no, depth, this thing, breadth, that one. I was writing all the algorithms that I could do. I don't know if you guys know Leet Code. So there's Leet Code and there's Hacker Rank. Those two were my best buddies. And then there was a book I was reading. I think something about how to ace your software engineering interview or something. So those three helped me a lot in my preparation to join the team. For my masters, I said I was technical enough, but I wanted to know how to um I didn't just want to know the implementation part. I wanted to know the design part, and that was the main reason I went to information systems and business analysis, because it helped me. It helped a lot with the design part. So the coding part of the course was not so much. I think we even did only one course on like active programming. The other parts were like data analysis, software test, no, software design. Yeah, those those were mainly it. So I did some research, and that was the course that I found for what I wanted to do. Uh, do my answers fit your questions, or do they answer your questions? All right, more questions. Please unmute and ask your question.
Hi.
Hi.
Please, mine is not really okay. Let me put it as a question. Has it ever crossed your mind to become a lecturer? If it hasn't, please consider becoming a lecturer.
Well, it hasn't crossed my mind, but
Retweets.
my mom has. My mom's a teacher, so maybe I got this one from her.
What? That's that. That's nice. You teach very well.
Thank you. Any other questions?
That's it.
All right, I think we are out of time, so I'll just hand over back to Mr. Mark. I'm so happy I met with you guys. Right.
It was nice meeting you.
Very happy to have met you too. Thank you very much.
Yeah.
Hello? Yes, it's true. What? I got it one way. Nah, you press them. Each. See what?
Good day, sir. Yeah, the pronunciation is Namakiran. Okay, thank you, sir. I wanted to ask if there'll be a recording for the virtual mentorship class we just had. If there'll be a video recording.
Sorry, can hear you. Go on.
Yeah, like I want to. Yes. I just want to ask if she's a first class student. That's
Ah, you want to shame me in public? No, I'm not. I was not. I was well. I came out with distinction for my masters. That should count for something.
okay. Okay. I mean, yeah, 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 yeah. Thank you.
Yeah, sure, man. Uh,
No, I
I
will
think I
thank
go.
our guest.
Okay.
So let
I'll
me.
go. Uh, so we just want to thank you, Ma, for engaging with us today. It has been a very pleasant experience. Even some of the things we learned, we actually got more knowledge about it today, and we just want to give you the thanks there. And we hope that your future endeavors will be a very successful one. Thank you very much.
Please no.
Sir,
Yes,
Sir,
sir.
please give us
sir,
a few
please,
minutes.
where is... Oh, okay, okay.
Sir, time.
Don't put that inside.
The link is not opening, please.
Sir, please, can you resend it?
Yes, please.
Sir, the link is not opening.
Yes. Yes, please.
Ah, the link is open. The link is open.
It's not
It
opening.
is open.
Sir,
Use
then
your
please,
student's mail.
Sir, it is open.
Well, it's opening for me.
sir, please. Sir, please, can you? Sir, please, can you send it through the Telegram group? Because I'm opening it on that and the chat session is not.
Maybe your default browser isn't configured with your PC also, I guess.
So I can also access it.
Only one. What's up? You say what's up?